Yes, yes. Hi, everyone. Welcome to our today's session. We are going to move forward. Today, we are going to talk about Chapter 5. Chapter 5 will talk about what we call Spanning Tree Protocol. Spanning Tree Protocol, STP, Spanning Tree Protocol, right? So I will try to share my screen and we are going to move forward, right? So I've started with the easiest one from chapter 7 and 6, and now we are going to do chapter 5, and I will go back to chapter 8, and you are going to get ready to start writing. Remember, guys, you do have only 2 chapters per exam, so it's much easier. Remember from Ccna 1, it was like three modules or 3 chapters for 1 exam, but now we are going to have 2 chapters for 1 exam, so it's much easier, right? Okay, let me try to share my screen. And I'm gonna prepare first my packets. Tracer, but I don't need it much today. So guys, we are going to talk about spanning tree protocol, right? So this spanning tree, we can abbreviate it as STP, right? Spanning tree protocol. Yeah. But in order for you to understand this concept, you have to put your mind on switches, right? So when we are talking about spanning tree protocol, number 1, we have to put our mind on switches. So spanning tree protocol is a computer program that will run on switches, right? Computer program, protocol that will run on switches, right? Yeah. I'm gonna pick up another color in order for me. So when we are talking about spanning tree protocol or STP, this concept will be related to switches, right? You must see the switches, right? And what is a spanning tree, right? Okay. So STP is a computer program or protocol that will run on switches, right? So it's a computer program that you're gonna use when you are dealing with switches. So your switches will use what we call spanning tree protocol, right? Number 2, you have to understand these switches always send broadcast messages to other switches or devices to connect it so when we're talking about switches, you have to understand that switches always send broadcast messages to other switches or to connected devices, right? What does it mean? So it means this. Let me try to draw something here. So when I have like this one, it's switch 1, right? And there is what? Switch 2. And there is what? Switch 3, right? Or maybe it's like this, right? And there is one of the PC. There's another PC here. PC2, PC1, and PC3. Right? So if PC3 wanna talk to PC1, right? So if PC3 wanna talk to PC1, right? What's gonna happen for the first time? Your message will go first where? Your packet or your frame will go first to the switch, right? To switch number 1, right? So what the switch number 1 now will do, for the first time, the switch number 1 doesn't know the MAC address of PC1, right? So the switch number 1 will send a broadcast message to all those 2 switches, right? So when those 2 switches will reply, now what will happen? Switch number 1 will build what we call a database, right? So switch number 1 will build a database. That database, we call it content addressable memories, CAM, right? CAM, right? So guys, what I'm saying is this. I do have like switch number 1, switch number 2, and switch number 3. And there are PCs there. Suppose like PC number 3 wanna talk to PC number 1. What's gonna happen? PC number 3 will send its message or its frame to switch number 1, right? Switch number 1 doesn't know how to reach PC1 because switch number 1 doesn't know how to reach like PC number 1. Switch number 1 will send a broadcast message. Broadcast message means that, so it's a message that will go to every devices or every switch connected to switch number 1. So when I'm talking about broadcast message, so I'm talking about a message that will be sent to all the devices connected to switch number 1. So switches always send what? Broadcast messages to all the devices connected to it. So switch number 1 will send messages to switch number 2 and switch number 3 by saying, guys, I want to talk to PC number 1, but I don't know how to reach there. So switch number 2 now and switch number 3 will try to reply, right? By replying, they are going to reply with what? MAC addresses of those 2 computers, right? So, and those MAC addresses will be created on what we call a database. So switch number 1 now will build a database. That database, we call it a content addressable memory, right? So this is the meaning. But now, see what can happen now, right? Suppose like you have switch number 1 here, right? There is, okay, let me do it this way. I want a big one. Right, I'm gonna do something big. So this is your switch one. There is port number 1, port number 2, and port number 3. And there's another one here, right? Switch number 2 with what? Port number 1, number 2, and number 3, right? 1, 2, and 3. There also there is 1, 2, and 3. And you're gonna have another one here, right? Switch number 3 maybe with port number 1, maybe number 2, number 3, maybe number 4, right? 1, 2, 3, 4. Right? Now, let's say a switch 1 is connected to switch number 3 by using maybe port number 2, right? So, and switch number 1 is connected maybe using port number 1, right? So, and there it's connected maybe, right? So you connect your switch number 1 to switch number 3 using port number 2, and you connect your switch number 3 to switch number 2 using port number 2. Right? Okay. And one side here, right? There are some computers here. Maybe this computer is plugged here. So you're gonna have another computer here, right? And you're gonna have another PC here, right? As we said, switches will send broadcast messages, right? So if this PC1 wanna talk to PC number 2, right? So what's gonna happen? Switch number 1 will send a broadcast message to all other switches, right? So if PC number 1, this PC number 1, wanna talk to PC number 2, right? For the first time, what's gonna happen? Switch number 1 will send a broadcast messages to all those other switches, right? Suppose like port number 1 will be used, right? Port number 1 will send a broadcast messages to switch number 3, right? To switch number 3. And all those other ports will receive the message, right? And when the message will reach switch number 3, switch number 3 also will send a broadcast messages to all those other ports, right? And this switch number 2 also will do what? Will send again a broadcast messages to all those other ports again. You're gonna see that by doing this, you are going to create what we call a loop, right? There's what we call a loop, right? The messages will start going from switch 1, switch number 3, from switch number 3, switch number 2, from switch number 2, switch number 1. You're going to create a loop. Now, by creating this loop, a loop gonna be created. What's gonna happen? Your switches will do what? Will crash, right? Switches will crash. Yeah. Right? Switches will crash. So did you understand? So what I'm saying is this. Switches required a database. Every switch need to know MAC addresses of every devices connected to it. But how to know those MAC addresses? Yeah. Switches will send what? A broadcast messages to all the devices that are connected to it, right? So those devices are going to respond with their MAC addresses, and the switch will keep it in one of the database that we call a content addressable memory, CAM. So it's just a database, right? Now, Suppose like you have like 3 switches, switch number 1, switch number 2, and switch number 3. Switch number 1 will send a broadcast message to switch number 3 and switch number 2, right? By asking, what are your MAC addresses, right? For those devices that are connected like to you. Now, switch number 3 and switch number 2 also, they are going to do what? To respond, right? By responding, they are going to create what we call like a loop, because some messages are going to do what? Going and come back. So switch number 1, so we send a broadcast message to switch number 3. Switch number 3 will send a broadcast message to switch number 2. Switch number 2 again will send to switch number 1. Number 1 to, right? So you are going to have what we call a loop. And by having a loop, that loop will disturb the communication between switches, between devices, right? Your switches will crash. Now, to avoid that loop, right? To avoid that loop, engineers, they came up with an idea, with a computer program that we call spanning tree protocol. So SDP is a computer program that will allow switches to avoid loop, right? Let me try first. So guys, we are speaking about spanning tree protocol, STP, right? So what does it mean? It means this: when you have switches like in your company, those switches, they have to know about MAC addresses of all the devices connected to them. How they will know? They have to ask. By asking, they have to send a broadcast message. Broadcast means one message that will go to all the devices connected to you, right? Like you're inside your house, you want to speak to everybody at the same time. So switches will send like broadcast messages to all the devices connected to it. So suppose like, so I am a switch. So I want to talk to another switch, because that switch got so many devices connected to it. So I want to know about all those devices connected to that switch. So I will send a broadcast message to that switch. That switch also will do what? So if there's another switch connected to that switch also will send a broadcast message to that other switch, right? And that other switch also will send also a broadcast message to other switches also connected to it. That will create a loop, right? So messages will start going and coming back, right? And remember, guys, suppose like I got my switch with 4 ports, right? And I'm using port number 1, like to send my broadcast, right? When the message will come back, so the message will come back to the remaining port, those 3 ports, not the one that I used to send, not the originated port, not that one. The originated port cannot receive the message that will be coming back, or the frame that will be coming back, right? You have to remember that. So guys, it's like easy concept, but you have to be careful, and you have to understand it like properly. So that way I'm going like slowly by slowly, right? So as I said, you have a switch, right? A switch is not like smart as you think. From the beginning, when you have a switch, your switch is empty. There is nothing. Your switch doesn't know nothing about all your devices that you connected to it. For a switch to know about those devices, right? A switch will send a broadcast message to everybody who's connected to it. A broadcast is a message that is sent to everybody, right? When those devices are going to respond, they are going to respond with their MAC addresses, their physical addresses. When they are going to respond, now a switch will build a database. So it's like you, a human being, for you to know like a particular road, for you to know about your mom, your dad, somebody must tell you, right? So the same thing as a switch, right? Now, when a switch is connected to another switch, that switch also is connected to another switch. That switch also is connected to another switch, right? So the first switch will send a broadcast message to the second switch. The second switch will send also a broadcast message to the third switch. The third switch will send to the fourth one. And if switch one is connected to the fourth one, the fourth one will send back again that message to switch number one. So you're going to have a loop, and that loop will make your switches to crash. Right now, to avoid that loop, the engineers, they came up with what we call spanning tree protocol, the STP, a computer program that will allow switches to avoid the loop. And remember, guys, we've been learning how to combine physical port to create a logical one by using the ether channel for port aggregation. And when we are dealing with ether channels, remember that we are creating redundant links. For two switches, we have so many links, right? And when you are using broadcasting, you're gonna see that from switch one to switch number two, suppose like you have 3 links, so the message will go to link number 1, come back to those other links, right? Now to avoid that, you have to run the spanning tree protocols on your switches. But by default, spanning tree is already so enabled by default on your switches. There's no need for you to enable it. So it's already like enabled, right? Now, this is what you have to understand about spanning tree protocol, right? Now, guys, we're gonna see now, right? So as I said, spanning tree will try to avoid the loop between those two switches, right? By creating what we call a loop-free topology. So your topology, your physical topology will be free. So spanning tree will create a loop-free topology, right? But how spanning tree will create that loop-free topology? How spanning tree will avoid that loop? This is what we are going to discuss now. We are going to see the processes that will allow your spanning tree to avoid the loop, right? So this is what we are going to see now, because you understood already the concept of spanning tree. Now we're gonna see the processes, like how does it happen, right? Just you as a specialist, how does it happen? Just to understand, like you have switch number 1, switch number 2, switch number 3, and they are connected to each other. How spanning tree will avoid that loop, right? You cannot like do it like basically, but you're going to configure. But I want to show you how spanning tree will avoid that loop to happen, right? Your responsibility is to understand what does it mean by spanning tree, why we need spanning tree. We need it for avoiding loops, and what is the process that spanning tree will be using in order to avoid that loop, and how to configure spanning tree, and what are the types of spanning tree protocol that we do have, right? So this is what we are going to see. Let me try to share again my screen. Yeah, so all right, now we're going to talk about spanning tree like process. I'm checking what I have to do. Okay, so STP steps, right? So this is what we are going to talk about now. So what are the steps that spanning tree takes in order to avoid that loop? we do have like 4 steps that you have follow, right? Step number 1. So election of what we call the root bridge. The root bridge. Number 2, root port, what we're gonna call root port. Number 3, designated port. Number 4, blocking port, right? So those are the 4 steps that spanning tree protocol will be using, because the main idea for spanning tree is to create a loop-free topology, to allow your topology not to crash by blocking some port, right? So this is the full idea of a spanning tree protocol. So it's to allow you to do what? To create a loop-free topology by blocking some of the port that will create loops, right? Now, the steps are, step number 1, spanning tree will choose a root bridge. This is step number 1. Don't mind if you don't understand, because you are going to understand it better. Step number 2, we are going to determine the root port. Step number 3, we are going to designate some port. We are going to choose what we call the designated port. And number 4, we are going to block the port. Spanning tree will block the port. So we are going to elect the root bridge for our switches. From the switch, we are going to decide what are the root port, and we are going again to decide what are the designated port, and we are going to choose what are the port to be blocked. So we have the root bridge, we have the root port, designated port, and the blocking port, right? So we are going to have like switches, right? Number 1, you have to choose a root bridge between your switches. Number 2, you have to choose your root port between those switches. Number 3, spanning tree will choose the designated port. And number 4, spanning tree will block the port, right? So I'm gonna give you just like an example. Okay, let's say we have those switches, right? So switch number 1, switch number 2, and switch number 3. Right? Switch number 3 is connected to switch number 1. Switch number 1 is connected to switch number 2, and switch number 2 is connected to switch number 3. So, and you got some computers there, maybe, if you want. Right? Now, you see that by having this, you are going like to have a loop. Now you say by yourself, I want a free topology. So I want a loop-free topology. So I don't want a loop here. So I have to run spanning tree protocol in order to avoid the loop, because my broadcast messages will start going from switch number 2 to switch number 1, switch number 1, from switch number 3, switch number 2, back to switch number 2. You're going to have a loop. Now we have to create a loop-free topology by using spanning tree protocol. Now, what the spanning tree protocol will do, this is where we are going to use those steps above. But switch number 2 will have what we call a priority. So a priority. Oh, okay. Let me just say P. Okay. Let's say the priority of this one is maybe it's number 10. Priority So of this one, number 20, from switch number 2 is like 20. Priority of switch number 3, let's say it's 40, right? So there's a priority for every switch. And you're gonna have MAC addresses, right? So MAC address for switch number 1, right? MAC address, let's say it's D MAC address of this one, we can say BBB. And MAC address of this one, we can say C. So you got your topology. Every switch will have a priority, like a number, and a MAC address, right? So for switch number 2, you got like its priority is 10, the MAC address is DDD, but so I don't want to write the whole number for the physical address or MAC address. I'll just make it short. And switch number 1, you got a priority of 20, MAC address is there. Switch number 3, you got the priority and the MAC address. So for every switch, you will know its priorities and you will know its MAC address, right? Now, how this spanning tree will proceed, right? So number 1, it's what? The selection of the root bridge, right? So we're gonna start with number 1, right? How to elect this root bridge, right? This root bridge will be what? When we're talking about a root bridge, we have to see the priority and MAC address, right? So when we're talking about the root bridge, you must look at what? You must look at the priority and MAC address, right? So for you to elect, for you to choose, for spanning tree to choose the root bridge, the spanning tree will start first by checking the priority. So STP will go for lowest priority, right? So your spanning tree protocol, to elect the root bridge, the spanning tree will check which switch got the lowest priority, right? Which switch got the lowest priority. So if there is a tie, tie means switches with same priority, number. So if there is a tie, like 2 switches with the same number, like 10, 10, STP will go for lowest MAC address. This is what you have to understand. So for electing the root bridge, spanning tree, we look at those 3 switches, right? Which one got a lowest priority, right? The switch that got the lowest priority will be the root bridge, right? But if there's a tie, or maybe 2 or 3 switches got the same priority, the switch will check which switch got the lowest MAC address, like in terms of the number. You're gonna see like AAA is lower than BBB, right? Or 111 is lower than 222. But let's go for, like in our topology, right? We are going to see that. So our lowest priority is 10, right? Because switch 2 got a lowest priority. switch number 2 will become what we call a root bridge, right? Switch number 2 will become a root bridge because the priority is lower, right? Now, so spanning tree, right? So the root bridge, you can also call it what? Like a central point. A central point. So the master of all those other switches. So this is your central point, right? So step number 1, we are done. Now we're gonna go for what? For step number 2, right? So for every exercise I'm gonna give like to you guys, you have to understand that step number 1, spanning tree, will choose the root bridge. What is a root bridge? The combination of the priority and MAC address. So the switch will start first, spanning tree, we start by checking between your switches, even if you got like 100, which one got lowest priority, right? That one will be the root bridge. But if there is a tie, like 2 to 3 switches, or all the switches got the same priority, spanning tree will check the MAC addresses, which switch got a lowest MAC address. So in terms of the numbers or the letters, right? Now, number 2, we're gonna go now for what? For the root port, right? What does it mean by root port, right? The root port, so if the switch or switches switch port with lower cost to the root bridge, right? So what does it mean by root port? How are you gonna choose your root port? You are going to go to every switch, right? Because those switches, they are connected to the root bridge, to the master switch or the central point. You are going to check their cost, right? What is the shortest cost to reach the root bridge? So you go to every switch, you said, okay, what is the shortest part, the shortest cost for me to reach the root bridge? Which port will allow me to reach the root bridge by spending less, right? So we're gonna go here. When you go to switch number 3, right? You can go to switch number 2 by going like this, or you can go like this, right? Let me show you the diagram. So, okay, which one can I switch color? Okay, or this one. So from switch number 2, so I can go like this to the root bridge, or I can go like this. My message can go like my frame, right? So you can go like this. So you can reach the root bridge from S3 like this by using this link or by using this other link. But if we are using fast Ethernet, right? Remember guys, fast Ethernet, for fast Ethernet, the cost is number 19. So means what? Means this. Means this link is 19. So if we are using fast Ethernet link 19, this one too is 19. So, and this one too is 19. So you're gonna see that when you are trying to go this way, your cost is gonna be what? 36, right? No, 38. 19 plus 19 are 38. But if you are trying to go like this, your cost gonna be what? 19. So this link, this one is the shortest one because the cost is less, right? So this one gonna be our root port. So your root port is gonna be this here, this link here. We're gonna call it a root port. Why? Because so it's gonna take less cost to reach the root bridge, right? Now we're gonna go to what? We're gonna go to switch number 1. We have also to elect what? The root bridge, no, the root port from the switch number 1, right? Remember again, guys, which color can I use? Yeah, you can reach the root bridge like this by going this way, or you can reach it by going this way, by passing by this one, right? So there are 2 ways switch number 1 can reach switch number 2. But by going this way, you're gonna see like the cost is less, is 19. But by coming this way, it's gonna be 88. That's gonna be a lot, it's gonna take time, right? So this link here, this one here, right? I don't know, my mouse is giving me a headache. Ish. Okay, which color I want? So this link, like here, gonna be like our root port, because there are 2, yeah, root port, right? The root ports. Now we're gonna remain with 2 links, right? I have a problem with my mouse. Okay, now we are done with what? The root port, right? So for every switch, we do have a root port. Switch number 1 is a root port. Switch number 3 is a root port, right? Now we're gonna go to what? Step number 3. Step number 3 means that we have to elect the designated port, right? We have to elect the designated port. Right? We're gonna elect the designated port. My mouse is just a bit slow, guys. Now you're gonna go here, right? What are the designated port, right? This is what we are going to elect now. So I don't know which color I'm gonna use. Okay, the designated port from the root bridge. So all the ports are designated D and D because they are two links. D, D. Those 2 ports, they are designated port, right? Now you're gonna see that you're gonna have 1 segment left here. So this one too gonna be a designated port. So and this one gonna be a designated port, right? Now you have 2 designated ports, means there is a loop. You see, from switch number 3 and switch number 1, there are 2 designated ports, right? Means there is a loop. We have to block 1, right? Let me write it down. Oh, my mouse is giving me a headache. Okay. Means there's a loop, right? 2 designated port. 2 DP means there is a loop. There is a loop. 1 port must be blocked. So this is step number 4. 1 port must be blocked, right? So which one now we're gonna block, right? Which one are we going like to block between this one and this one? Which one are we going to block? Right? For us to block now, what we're gonna do, we have to check again the priorities of those two switches, right? The priority. You're gonna see like there is priority like 20 from switch number 1, and switch number 3, the priority is 40. Means that switch number 1, it's fine because the priority is less, it's gonna remain on designated port. So on switch number 3, because the priority is higher, we are going to block this port. So this port is going to be blocked. So spanning tree will block this port. This is the blocking one, the one that we're gonna block. Right? So this is how spanning trees create a loop-free topology. They won't gonna ask you to do all those things, but you have to understand how to pick up a root bridge, how to pick up a root port, how to pick up a designated port, and how to block a port. I'm gonna take the last exercise in order for you to understand, right? I'm gonna start over. I'm gonna give you another exercise, guys. Okay, let's say we do F again, like one switch here, maybe. Oh, my mouse is giving me a headache now. Pick my mouse, okay. Going on, it's too slow now, my mouse. I don't know what must I do now. So switch number 1. So switch number 3, number 2 maybe here. Oh, I cannot even write again. I have a problem with my mouse, guys. I don't know what to do now. My mouse became slow. I don't know why. What's going on? I have a problem, guys. My mouse became slow. I have to fix it. I have a problem with my mouse. I don't know what. I don't know what to do, guys. I got okay, guys. So I got a problem with my mouse. I don't know what to do, but I will give you an exercise. I cannot draw it like anymore, right? But I will do like another video using my pen, right? It's very hard for me to draw, right? So I'm gonna use my pen and send back to you. Okay, let me check. So if I can use my pen now, I'm gonna just take my camera and fix it on my, because now it's a headache for me. That's 1 minute, guys. Let me try to stop sharing. So guys, I'm gonna have here like 3 switches. Switch number 1, I'm sure you can see. Switch number 1 goes to switch number 2, and switch number 2 goes to switch number 3, right? There are 3 switches. My priority here is number 2. My MAC address is 222. My priority here. My priority here is number 1. Even camera, it's a headache. My MAC address is 111. My priority here is 3. My MAC address is 000. Right? Let me try to fix my camera if you can see. You can see it properly. I don't know what I have to do if I have to do it like this. There's a problem here. Still, fix this camera. So, okay, guys, so I cannot use my camera like properly, but I'm gonna send you like another video just now, right?